All right, welcome all you gophers to GoLab 2020, the very last day for this year. We're happy to have you here, and we will introduce you very quickly to our speaker for today, Salman Bilal Shah. He is going to tell you all about building an event-driven microservice using Kafka and MongoDB in Go. So welcome, Salman. Can you turn on your camera and microphone so we can say hi to everyone? Fantastic. There
Hi.
you are. Hi, great to have you here. Welcome to
Thank you
GoLab.
so much. Thank you so much.
We're very happy to have you here. So, for
Thank
those of you who don't know, Salman is a software engineer currently working at Myntra Designs PBT Limited, having been working with Go after working with Ruby on Rails for over 2 years. He is passionate about speaking at tech conferences. He's an aspiring developer advocate with a mission to bring about positive change and work on impactful projects. So fantastic to have you here. And about the talk today, we'll talk about how an event-driven backend microservice used by Myntra, India's largest fashion e-commerce retailer. The talk covers the decisions to move from NodeJS to Golang, design choices and learnings during development, and the journey to production supporting more than 22 million active users. So this talk is an event-driven system using Kafka and MongoDB in Golang. It's based on the speaker's experience with working with Golang as a developer at Myntra. The speaker dives into the details of designing and scaling event-driven systems, serving millions of users in the Indian fashion e-commerce industry. So we're about to hear that talk. Thank you so much. Do you have anything to add before we watch the video?
So I think this talk is oriented a lot towards people who are probably starting out and who are probably trying to understand Go as well. There is a fair bit of understanding of the system that we've tried to design over here, and I've given a quite an introduction to event-driven systems. So I think we'll go over those during the talk, and once we have any questions, I think we can take them during the once the 20-minute session is done. And yeah, I think that's about it. Thank you so much.
Thank you. All right, so everyone sit back and enjoy. This will be in two parts. We'll have a break in the middle, and if you have questions for Salman, please direct them towards the Q&A chat. We'll answer them at the very end. So sit back, enjoy, and we'll talk to you at the end. Thanks.
Hi, good morning, afternoon, evening, night, wherever you are watching the stream, and thank you for attending GoLab 2020. What we're going to do right now is we're going to have this talk, and let me give a short introduction about myself. So my name is Salman, and Salman Shah, full, and I'm a software engineer working at Myntra, and I've been here for about year and a half almost, working with Golang primarily, and working on this particular microservice as my primary project over the past few quarters. So what we're going to do today is talk about how to build an event-driven microservice using Kafka, MongoDB, with Golang. So this talk primarily reflects on my experience and some of the learnings that we've had in general at Myntra, working with event-driven, working with technologies like Kafka and MongoDB when coupled with Golang. And we're going to talk about our journey of how we started with a different set of technologies, primarily Node.js and RethinkDB, and have now ended up with Kafka, MongoDB, and Golang. So let me move on to the agenda of our talk. So this is going to be, they're going to be two sessions that we're going to have, and as part of the first session, we're going to cover event-driven systems history and the design decisions that we've taken. At the end of the session, we're going to have a small Q&A where folks can reach out in case they have any doubts or queries with respect to this talk. So having said that, I think let's move on to the next slide. So we're going to do a quick understanding of what event-driven systems are, what are various terminologies that we use or different layers in an event-driven system, and then we're primarily going to move on to some of the main topics of this talk. And in case you have any questions, we'll take it at the end of the talk. So moving on. So let's try to understand what event-driven systems are, and I think this is one diagram which I think will be very, very easy for a lot of folks to understand. So let's primarily look at this part of the talk, this part of the diagram. So this part of the diagram is primarily what I think most of us are aware of and have primarily used, which is something called as a server-client system. So you have a server, you have a client, you make a request, you get back a response. And I think that, and what happens is, let's say you send some request to add some, so you have 4 operations: CRUD, create, read, update, delete, and based on the operation that you would have an interaction with your database, and the database would return a response or create a certain entity within the database. So that is the traditional legacy system, or legacy system distributed monolith as we call it in this particular diagram. Now this is what all of us are familiar with, and being the traditional architecture. What we're going to do is we're going to move slightly away from this and talk about what exactly event-driven systems are and how they're used. So there are various components in an event-driven system, and a very basic diagram is this. What would happen in this particular scenario is we would move from the client app, or the client as we call it, to something called as the command service. This command service would write data and store data. So the first, let's try to understand the first flow. The first flow is us writing to an event store, where we would basically store our data depending on the CRUD operation that we have. Okay, so in our use case, we basically have create and update for this particular flow. What we would also do is parallelly write to our Kafka. So what would happen is we would be writing both to an event store, in our case that is a MongoDB database, and to our events message broker, which in our case we use Apache Kafka. Okay, so and one of the primary reasons for sort of having an event store also is the fact that Kafka does not store data permanently. Its main use case is that of a streaming service, and by default, if I'm not wrong, Kafka has about 7 days worth of data storage. So anything that is written to Kafka by default, of course, you can always manipulate that number for a period of 7 days. You would eventually store that data. So this is, and what today's talk is going to be is basically talk about these 3 components, which, as mentioned in the topic initially, Golang, MongoDB, Kafka. I hope we're able to map this over here. All right. So moving on, the next part of this is something called as a query service and a projection store. So what we're going to try to understand is everything that happens after the events message broker. These could be one or many services. So there could be one or many services reading from this query, from this events message broker. And also another important thing is the projection store that we have might or might not have the exact same fields, number of fields, or there could always be some sort of manipulation, or there could be always some sort of difference between difference in terms of exact data between event store and projection store. So what this could mean is, let's say if you're storing five fields over here, you would typically store, let's say, maybe 3 or 2 fields over here based on your use case of what your query service is. Okay, so I think this is the first step that is there in trying to understand this model. Now, what also happens is, let's say if the client app requires the information that it has sent. So in our CRUD operation, let's say we want to read some particular information. So let's say there is a particular ID which, let's say, the client stores within itself, or some unique key which the client has, which it has already sent to these databases. It queries via that unique key, unique ID to the query service and not to the command service. And of course, the query service would return that data based on what the client requires. This is a simple request response sort of flow, if we could call that. Okay, so now what we are also going to talk about today is we're going to, while we've understood this entire mechanism, we are in the next particular slide we're going to understand some of the terminologies behind event-driven systems. So moving on to the next slide. We're going to talk about event flow layers. So typically any event-driven system would have 4 event flow layers. The first one would be the event generator. So the place where you are eventually generating events. Second, the channel or the mechanism by which events are flowing to the third layer, which is your event processing engine. So and event processing engine is where certain actions are taken. So what would typically happen is, let's say a very simple example. Let's say I have 3 fields of my install. Let's say I'm storing the GCM ID, which is required to send out notifications to clients. Now, a client in the initial flow, the client would have its GCM ID, which it would obtain once a user has installed the application on their device. Now, the eventual goal is to send this to a service which does notifications. Now, one thing that is very important to understand is our command service will never send out those notifications. It will only store information with respect to, or it will serve as a mechanism to not even store, in fact, for that matter, it will just serve as a mechanism to send out information. Okay, so let's look at this flow, right? So let's say there is GCM ID which has to be sent, and what would happen is the client would call a command service sending a GCM ID. It would write to our MongoDB, it would write to our Kafka. This would further go to the query service. The query service would write it to the projection store. Now, while we've explained the use case of sort of querying back this information, what we're also going to do is understand there could be more services which provide further actions, which would not just be in the form of querying. So coming back over here, we see this event processing engine, right? So event processing engine would be basically the service that we have, and what we would do over here. So event processing engine is basically this part. Instead of the query service, you have, let's say, a service, event action service. Okay, and this service would have multiple actions to it. So let's say once I receive a GCM ID, I send a notification back to my app client saying, hello, I have received a message. Okay, so that would basically be a notification. And once I have obtained his GCM ID, what I would do as part of my event processing service is I would send a message back to the client saying, or maybe if this is at the beginning of when a client signs up, we would send it back saying, welcome to Myntra customer, and here are things that you could do as just as a push notification. So that is what is referred to over here as downstream activity, or various operations that we could typically follow. This could be in the form of SMS messages, this could be in the form of emails, and so on and so forth. So this is the entire concept of event flow layers that we have. I hope things are clear. In case they are not, please do note down your questions and we will take them at the end of this talk. So moving on, history and technologies explored. So we're going to talk about some of the technologies where we started with and where we eventually are right now. And what we are going to do is, so for us, the primary move was from, so we were going to talk about two things primarily. Why we moved away from NodeJS, which was our initial technology base, to Golang right now. And there have been several reasons for this, and this has been a very recent shift that has occurred for at least our event driven service. So but overall we've been moving from NodeJS to Golang, and this has been sort of an operation over the past 3-4 years, even before then, when I was a part of Myntra. So I think for us, moving away from NodeJS to Golang worked primarily on 3 major reasons. The first one being performance. So when it comes to performance, Golang outperforms MongoDB, and this is basically just in terms of raw processing power. Golang is far more far more effective, and I think one of the major design goals of Golang was to ensure faster and greater performance. But when it comes to DB interaction, so let's say you are supposed to, you have to compute the time of writing to a MongoDB. Between a Golang service and a Node.js service, that time is absolutely equivalent, almost equivalent, based on various benchmarks that have been run. So while doing network calls of writing to a database, or even for that matter an event streaming service, both perform equivalently under similar conditions, of course. So I think that is where they're sort of still equal for that matter. Second is concurrency. So I think Golang has been built for concurrency, and that is one of the major reasons why Golang has come up as compared to Node.js, which is single threaded. Node.js does sort of try to achieve a form of concurrency via event callbacks, but that is not something that sort of significantly improves its concurrency metric. And Goroutines are essentially, just for the sake of information, Goroutines are essentially user level threads that are created during within Golang itself. It's a Golang inbuilt construct, and I mean Goroutines perform a very effective way of using concurrency in Golang. And I think the third and the most, and not I would say the most important, but the third major difference and advantage that Golang does perform is having explicit checks over versus try-catch mechanism. So I think this is again a point of equivalence between the two, where error handling in Golang is explicit with respect to error checks. So I think there are very popular memes with respect to this, where after every operation that you have in Golang, there is an error check that eventually comes up, and this could be just in terms of making network calls, versus something as simple as just unmarshalling your JSON based on the the data that you've received from, let's say, a client. So that is one thing which Golang provides, which is very explicit error checking. However, Node.js on the other hand provides a try-catch mechanism. Uh, and while that is something that a lot of developers are very comfortable with, especially ones moving away from the Java world, or coming from the Java world to Node.js, or coming over here, but that obviously has its own benefits. So moving on, why Kafka? I think this is a very important question, which a lot of people do ask, and I think these three reasons answer it. And of course, there are a lot more advantages to Kafka, but primarily Kafka works as a high throughput service. So for us, our use case was primarily to have high throughput and sending out high throughput messages from our system. So for us, the number of messages that we get over a very short period of time, especially when it comes to sale events that we have, there's a huge stream of data that has to be sent, and ensuring high throughput with low latency is something that Kafka achieves very brilliantly, and that allows us to have retain Kafka, Apache Kafka as an event streaming broker. The next is scalability. So in terms of being scalable, Kafka outperforms a lot of its competitors. And while we're not going to talk about whether Kafka is good, this is bad, this that, what we're trying to stress over here is how addition of parallel nodes seamlessly allows Kafka allows the brokers to scale much more efficiently. And I think the third and the most very important reason that we would typically have is batch handling capability. So essentially what would happen is once you have a streaming service, right, what you would typically do is you would batch your requests in a certain number. So you would, let's say, multiple clients are obviously parallelly calling you, and what you would typically do is batch each of these calls. So have certain batches and send out that information. This allows your Kafka not to what this does is ensures that your Kafka does not get choked, and at the same time allows you to broadcast messages by also reducing the network calls that you have to make. So instead of sending one message sending a message every time over the network, and obviously network calls are expensive, are just expensive over sort of batching them together. So batch handling capability is something which is very important, and which based on the numbers that you tweak, improves the general health and performance of your system as well. So I think that's about it, and that's about this session. So here are some of my credentials if any of you do want to reach out. We will discuss more in the next session, and we're going to talk more about what the different features of our system and some of the learnings that we've had. Till then, thank you so much, and thank you.
All right, everyone, we are going to take a quick 5-minute break. So we'll be back here around 39 after to start the next session. Thank you. Have a good break. All right, everyone, welcome back from our break. Here we are ready again for the second session. So enjoy and see you at the end for the live Q&A session with Salman.
Welcome back to the second session of GoLab with my talk building an event-driven microservice using Kafka and MongoDB with Golang. And my name is Salman Shah, working as a software engineer at Myntra. So in the first session we talked about how how an event-driven system comes into place and how we managed to build an event-driven system or microservice for that matter using MongoDB, Kafka, and Golang, and also touched upon some of the concepts that were in place. Now, what we're going to do in this session, and which is what I come to, is basically talk about some development tips and going into production, what are things that we've seen and items that we would like to discuss and cover. So these are the 2 points of agenda, and let's move on. So over the course of this next 15 to 18 minutes that we will be having, I'll talk about some of the reasons and some of the tips that we've taken and the learnings that we've had from these, as also understand why these are critical towards building event-driven systems. So the first one, so before we move on to the first one, just want to cover one concept for those folks who are not very clear with those. So at the core principle, what we're trying to do over here is understand what Goroutines are and have a simple example to elaborate this further. So essentially Goroutines are basically functions which occur concurrently, and these functions are extremely lightweight, so which means they're highly inexpensive to create, which also allows us to create a number of these to run the show parallelly. So if we remember, in the first session we talked about why Node.js failed quite a lot at concurrency due to its single-threaded nature. And now what we're going to do is try to understand how a basic Goroutine works with a simple example. So over here I have a Goroutine. Let's start with here. So every Golang every Golang program has a single Goroutine, which is also known as the main Goroutine. So what happens is, every time you start a Golang program, you create an initial main thread or the main Goroutine. From this main Goroutine, you can spawn other Goroutines which can run parallelly or concurrently to your Goroutine. These might be initialized at the same time. Usually there's a very small difference between firing two Goroutines, because firing Goroutines does not happen concurrently, it happens one after the other. So over here what we're doing is we are firing two Goroutines, one which prints out alphabets, a certain number of alphabets, in our case 5 alphabets, and one which prints out serially numbers from 1 to 5, and each of these operations have different frequency of occurring. So over here you'll notice we have a frequency of about 250 milliseconds that we're moving from, and for the alphabets it's about 400 milliseconds. Okay, so now what we're doing is we're trying to understand how an output for this program would look, and also the fact that when we look at the final output, what is the advantage that Goroutines offer us. Now, if you look over here, alphabets printed at frequency of 400 milliseconds. If you look at the final output, we'll see that this is basically a sort of a combination of both of these, or an overlay of both of these onto the final output. And since these occur parallelly streaming to our output stream, what this also allows us to do is run these events parallelly without having to worry much about how to figure out the detail level implementation of it. And we will take a simple example on how to use Goroutines. So this is a very straightforward and simple example to understand how Goroutines work. Your output would need not be back to back, and once a Goroutine has ended, the other Goroutine will continue to go on, and these Goroutines can be fired as many and parallelly as possible. Okay, so that's about Goroutines. Let's move on to the next slide. So the first step that we have over here is basically use Goroutines, and use Goroutines to parallelize network calls to MongoDB and Kafka producer. So what this means is, if you remember in our first talk, we talked about how initially when the client calls our service, we have two places to write. One is the database and one is the Kafka stream. So in our case, MongoDB and Kafka is basically where we are writing our input to. And the first step that I have is to write both of these using a Goroutine. So essentially you have a Goroutine which one Goroutine for your MongoDB and one Goroutine for your Kafka. This allows you to parallelly write to both of them, and since neither of them are interdependent on each other, this allows you to complete your process together. Then this is just a simple example of how a Goroutine works. There are two ways to initialize your function and then to basically call a Goroutine. One is you define the function separately. So let's say you have a function called f and you pass an argument to it, and another is you define the function there itself and you write the operation of the function. Okay, so I mean, either one of these works depending on what implementation that you have. But what we're doing over here is calling our MongoDB package and our Kafka package, or the underlying library for MongoDB and Kafka, and making calls to them while parallelizing using Goroutines. So let's move on. So the second tip is to use defer, panic, and recover. So what are these? Each of these things, let's cover them one by one. So firstly, defer is a Golang inbuilt construct used to sort of, so the basic functionality in defer is basically call the function, method, whichever that is, at the end of the current function that we are. So defer essentially has a call stack where, let's say, if you have multiple defers, you keep writing them to a separate defer stack that you have. And once this function completely ends, so once we are over here, then we go into this function and read the values from that function. So that is essentially the idea behind defer. Panic is a separate built-in Go feature. What panic does is, and this is somewhat what we could say unique to Golang with respect to, it basically stops the program flow once you receive an error, and your could be the equivalent of what we call as a program crash. So your program immediately terminates once we receive a panic, though that might not be the case every time. So that is we will talk about why that might not be the case. So panic is the built-in Go feature to stop program flow, and the third one that we have is something called as recover. So what happens now is, let's say we fired multiple coroutines, and while we are firing each of these coroutines, while we are firing these coroutines, one of these coroutines has panicked. Now, once these coroutines have panicked, ideally we do not want our program to crash. So what we do in such cases is we write a recover. What a recoverer does is it allows you to regain control of the panicking coroutine, and you define a particular either a function, or you define a certain flow that carries out once you reach the recoverer. Now, this is a simple implementation of therefore panic recoverer all in one. What we're doing over here, we are calling the function f from the main function, and we have a defer. So in the defer, what we're doing is we're checking for the recover. If we have something to recover, we are just printing it out, and then we are calling another function g, where you would essentially be calling a Goroutine. Okay, so now we can see how the recoverer, so in case there is a panic, the recoverer immediately takes care of this, and this is one particular advantage, and also necessary, because in our case we are using Goroutines while we would do our create and update flows. So it's essential that while defining Goroutines, a recoverer is there to handle in case the code panics. Now moving on. So the third tip that we have is basically use sync.once for initialization. So initializing config parameters, so the idea is that all of us would have a config file, and what would happen, I think, yes, that is, yes, okay, so I think that's better, sorry. So the idea behind using sync.once is essentially to ensure that we are calling a certain function only once, and this is very true for config related functions. So let's say we have a function where we are reading from a particular config file. Now ideally we do not want this function to be called again and again, and what typically we do in such scenarios is use sync.once. So what sync.once does is it stores in an in-memory cache and ensures that we call a particular function only once. So once the function is called, it even though you would call it again and again, it wouldn't execute that particular or execute all the flow in that particular function. So for example, a very simple example before we move ahead is let's say we are printing a particular statement, and now in a for loop we are firing a Goroutine and calling this function multiple number of times. So what this allows us to do is, even though we call this function again and again, the final output would allow us to print this function only once, and that is the idea behind using sync.once. We primarily use this for initialization for config files. So let's say if you're reading from a particular config file, let's say you are reading config parameters for your MongoDB and your Kafka. Ideally you wouldn't want that function to be called again and again. Second, while your program is executing, you do not want, even if someone looks to change your config files, you do not want your program to change those particular config parameters at runtime. You would ideally stop your service and then maybe restart it if there is some sort of changed config. So that's about sync.once. Moving on. So before we move ahead and talk about the last 2 points, and we have about 5 minutes to do that, what we're going to talk about is basically the Go library that we're using for Apache Kafka, which is basically Sarama by Shopify. So if you here's a short link of the repository for Sarama in case you'd like to check out. And the requirements for Sarama is basically having Apache Kafka version above 0.8. Alright, so moving on. Yes, so now coming to using Kafka, basically the Kafka part in our entire system. So another dev tip that we have is using or preferring to use an async producer. What this means is basically, so this is a simple execution of a producer of the time when your Golang service would call Kafka. So let's say you call the send function, which is essentially what we use to sort of send a message from your Golang service to Apache Kafka. From your producer, you would basically call the producer network thread and to determine which partition you will be calling. Once we do that, what essentially happens is Kafka allows you to send a message to the leader. So a couple of quick terms. Bootstrap server is the one which essentially runs your zookeeper and allows you to find the leader. The leader is where you write, and ISR refers to in-sync replica. So essentially you would have a copy of your data in one particular broker or another particular broker, and that would allow you to write to one while ensuring there is a fetch and sync between two Kafka brokers. Now there are two types of producer types when it comes. One is something called as an async producer and one is something called as a sync producer. What happens in a sync producer is you do the complete write and then you get back the values. And in async, what we do is once we call the Bootstrap server and once we know what the leader is, we add it to a local queue to complete batching, and we return back that particular information. Then at a later point, once the response or once we are successful with writing, we do a call back to return an error or a successful message, as is the case. So the reason why we prefer async producer is that it allows us to write at high throughput with lower latencies. You do not have to wait for the entire flow to go and come back before or rather wait for the message to write to the leader before you finish your Goroutine where you are executing your Kafka send message. So that is another tip that I have. And the fifth one, and something which is pretty usable across projects, is to ensure individual components are unit testable. So we are using a framework called Testify, and what Testify allows us to do is write code better. There are Golang in itself has its own unit framework library, but over time we've seen Testify to be more reliable. And the usage of assert in Testify is something which a lot of developers are comfortable with. So that is something that we have been using as well. Alright, so I think we have about a minute left. So going into production, I think this is a service which we worked on for quite some time, and while the NodeJS version is live, the Golang version will go live within the next few weeks, And going into production, I think one thing that's important, and some of the observations that I've seen, is to ensure each of the code, be it unit tests, integration tests, and finally the top level functional level testing that we have, each of these testings need to be ensured, and edge cases are often very common. So a producer not syncing, or so the difference between going from local to production is often the fact that we're able to catch a lot of issues on production which are needlessly not captured on our local system. And all right, I think we are towards the end of the talk. So once again, this is Salman Shah signing off from GoLab 2020. In case you'd like to check us out, we are live at Myntra.com, an Indian e-commerce retailer. And I think that's about it. In case you have any questions, we can definitely take that up and discuss. Thank you.
Okay, everyone, welcome back. We are ready to go live with Salman to answer any questions you have. So let's go ahead and bring him on.
Thank you.
Oh, it's thinking. There it is. Hello, Salman. Welcome. Yeah.
I think I'm live now. Yeah.
Fantastic. Yes, I can hear you perfectly. First of all, I want to thank you so much for your contribution to GoLab. You know, even though it's virtually this year, we're really happy you could make it.
Thank you so much. Thank you so much for having me as a speaker.
Yeah, definitely.
Yes.
Absolutely. So before we get to any questions people have, was there anything you wanted to say in participation about your participation in GoLab?
I'm so sorry, I didn't catch that.
Sorry, yeah, I'll say it again. Before we get to questions, was there anything you wanted to say about your participation in GoLab this year?
Sure. So I think GoLab 2020 is probably the first talk that I have both attended. Attended as a speaker, and I think it's been quite an experience. I started my talk initially with above an hour and a half, and then I eventually trimmed it down. And I think sort of creating a talk and creating a topic which people are interested in is quite something which needs practice, and hopefully would love to get better, would love to do it again back over here, probably next year, and probably when all of us can probably meet in person when it's much safer out there.
Yeah, fingers crossed for the next event being live.
Definitely.
For sure. Okay, well, let's go ahead and see if there are any questions. I don't see questions, but I have a wonderful... Oh, yes, we do. Okay, so we have one question from John Greenwood. He says, thanks for a very interesting talk. And in your opinion, what do you think is the strongest advantage in adopting an event-driven architecture?
Sure. Thank you for the question, John. So I think event-driven architectures are primarily driven by the that you have at that point in time. What I have seen over the past few years with me working with, or the past year that I've been working with event-driven systems, is I think one of the strongest advantage that you have while building an event-driven system is the fact that you can communicate to multiple services your data processing layer. So for example, a very simple example, for us, we have about 2 to 3 services. Once we write to our Kafka, which is our data processing system, we have about 2 to 3 different services which each of them do their own parallel operation which is required from the data that we send to them. So I think that is something that powers and that helps, and given the frame of microservices that we have, really helps out a lot. So yeah, I hope that answers your question.
Great.
And if
Thank
you
you for
have a
that.
follow-up, yeah, if you do have a follow-up, we can definitely take that up as well.
Sure. Yeah, we'll give people about a minute to write any other questions. In the meantime, Mateo Benchi, he had a comment that I love too. Beautiful background choir in your video. We were all
So I
enjoying
think
that.
that was something very unintentional, and I think that was something that was happening somewhere nearby. So I think I was recording this talk at about 5:30 a.m. And back in India here, I think that is around the time where morning prayers are held
Sure.
across various places here. So yeah, I think something very unintentional, but it just came in, and yeah, thank you so
It-
much for that.
yeah, it was lovely to hear a little accompany music while
So
while you were doing it. All right. Well, I don't see any other questions for you, so hopefully that means everyone understood you very clearly. So I'd like to just end by saying thank you again, and hopefully next edition we'll have you we'll have you live for next time.
definitely would love to be there. Thank you so much.
Yes, thank you. Yes. Good job. All right. Well, thank you. We'll go ahead and say to everyone if they want to talk with you through GitHub, you left your contact information there. In case anyone has questions, they can direct them to Salman. So thank you for that. All right, Salman. Well, we'll see you around, and
Thank you so much.
hope you enjoy the rest of GoLab. Thanks.
Thank you.
Wonderful. So everyone, if you have enjoyed this talk, you can rate it on the agenda page of the website GoLab, and we'll be waiting for you for the next talk of the day, which will be best practices on writing a Kubernetes operator, my lessons from Capsule. So that's going to be happening in about 14 minutes. So hope to see you there. Thanks.